for watching. I'm working more on my stock market model today. Before I get started, I'm going to go over my progress and my goals and where I'm at. So, so the first goal is beat the S&P 500 by a significant margin and make money in all regimes. So I should never be losing money no matter what. And I'm writing all this in Python. So the second goal is to create a tool that anyone can use to create the models for themselves. So this is the layout. Basically, you don't want all the stocks that exist. You want to isolate good stocks. You do that with the stock universe. Once you have that, I'm making a returns model. It's predicting returns for the day, returns for several days, probability of a positive return, returns normalized to the market, things like that. And once I get a good model going for that, I'm going to incorporate it to a portfolio model. So a few weeks ago, I had a really good model here, but it turned out to not be so good. And then the last few days, I've been improving this model here. So I got a really good model right here. I guess this is it. So I care about the information coefficient, standard deviation of the information coefficient to information ratio, both on a daily and annual basis, and the t-statistic. So I'm hitting my thresholds for all of these, and I wasn't able to improve this at all. I tried adding sector neutralized features, but that didn't seem to improve anything. So I have to figure out how can I improve this more. This is the model results. This actually is basically really good. It's really good, but not quite good enough to implement. So it was good. You need an information coefficient above 0.01. And 2025 was the first year it fell off with an information coefficient below 0.01. So I just need to squeeze a little bit more performance out of the model. So let's see if there's any ways I can do that. Okay, look again at the model. I have I should put that down. Put this guy here. So what is that? Neutralizing to sector. Oh yeah, I already got that. So it performs worse if I'm adding in the sector neutralizations. But the information coefficient's good. So actually I'm going to do a walk forward analysis of this and see if the results are sufficient. So model 21 walk forward. No. Where is it? Here. Model 21. Okay, so it should be all of this and then the walk forward. So define features and targets. Oh, I need to update the code real quick. Okay. Symbol. Data. Oh. Oh, I need to push. Okay, good. Alright, so I have model 21. Now I need to do a walk forward with that. So what are the changes I made? So it was good enough here. I guess I'll look at improving the model after I do the walk forward. Yeah, let me see what the changes are that I made. Model 21 is worse on every metric. Removed skew and kurtosis short term. Changed AR input to raw. SMA, EMA, skew kurtosis. If windows greater than or equal to 20, add skew and kurtosis. Yeah, so that's all the same. $50 trials. All right, test walk forward. Train years 7, validation years 2, test years 1. Train years 7, val years 2, test years 1. That's fine with 40. Okay, so maybe this will increase performance for 2025. Let's see, so Model Explorer, Test Walk Forward, Model 21. Okay, good to go. Run it. Okay, now let's see. Give this to the AI. Your suggested changes other than this one did succeed at improving results. Is there any other way to improve these features? Here is the code. So here, first screenshot. here is the code for the walk forward on this model. The second screenshot is the walk forward results for this model. I just need to squeeze A set to a bit more performance out of 2025. All right, let's see what it says. And this guy should be running 2020 to 2021. Oops. All right, I gotta go and exit out of stuff. Well, did oh, here we go. When a theoretically sound idea, sector neutralization actively destroys out of sample performance. Alright. First principles explanation of why the sector features failed, why 2025 collapsed. Oh, was that the walk forward? Oh. Why did a 5-day model suddenly die in 2025? A 5-day target is fundamentally a mean reversion strategy. Mean reversion thrives in high volatility, highly dispersive. Low volatility, okay, like in 25. Cross-sectional dispersion. All right, let me look that up. Indicator of market heterogeneity and idiosyncratic risk. Commonly measured as the cross-sectional deviation. High CSD implies a wider divergence between the best and worst performing stocks, often used to gauge opportunities for active management. Implies a wider divergence between the best and worst performing stocks. Okay. You need a feature that divides end day momentum by end day volatility. The current target is forward log return cross-sectionally z-scored. Forces the model to pick the absolute highest returning stocks. In a weird regime, highest returning stocks are often unpredictable. Oh. Okay, so forward sharp. Does improved model 12 work better on a forward sharp target? Okay, the problem with, all right, let me add in something here. So factors, features for portfolio level model. Okay, volatility index, treasury rate features. Something to do with real estate. Real estate trends. What are we on now? 2021. Okay, it's on fold too, so I'm gonna stop this guy. Does improved model 12 work better on a forward sharp target? Okay. So forward sharp target instead of forward log return. Okay. Test model 12. Okay, so call it model 21, 22 is equal to 1. Model 22 same as model 12, same as improved model 12, but the target, okay, same as improved model 12, but target is forward sharp. Okay, so let's go to test model 12. Call this guy test model 22. Turn that guy off. All right, model 22, but the target instead of forward log return is forward sharp. Model Explorer, okay, run that. Okay, so the problem with, I need a fucking notebook. The problem with three features to fix 2025. Cross-sectional dispersion is that this value will be the same for every stock. Therefore, the model won't be able to learn from this. Assess whether this conclusion is correct. All right, so that's the first thing. New slide. Whoa. Battery is not charging. Why? What the fuck? Battery is not charging. Okay, good. Alright, so does improved model 12 work better on a forward sharp target? does volatility adjusted momentum improve? Am I running this? Oh. So shadow feature reduction makes it worse. So get rid of that. Am I doing that? No. But am I doing it on model 21? No. Does volatility adjusted momentum improve model 12? Okay, model 22. Forward sharp. Alright, does model 12 work better on a forward sharp target? Also, does volatility adjusted momentum improve model 12? Does volatility adjusted momentum improve model 12? Okay, trial 3, trial 4. See any comments? Nope. Okay. So model 22. Oh. Model 12 with volatility adjusted momentum feature. Method the LightGBM uses is to leverage the cross-sectional dispersion feature. This involves the tree's architecture and how the root node splits. Oh. Two-level uncertainty for safe deployment of cross-sectional stock rankers. Machine learning models for cross-sectional equity. All right, show me some tables. Signal. Yeah, whatever. So what I need is a 5-day model and then a 20-day model. Okay, it's finished improving basically. Real estate trends. Market level averages. NASDAQ. S&P. Dow. Cross-sectional dispersion paradox. This value will be the same for every stock, therefore the model won't be able to learn from this. Oh, oops. Features identical all stocks on a single day. All stocks on a single day. As opposed to treasury features, which take a long time to change. How does the volatility, yeah, that's fine. What? Log return for Tuesday evaluates the natural log of Tuesday close divided by Monday close. This logic should be fine. The buys are happening at market open, not market close. Reassess. Holy shit. 0.05? What was this change again? Oh, forward sharp target. Whoa. Oh my god. Whoa. Whoa, 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 whoa. That's crazy. That's unbelievable. Holy shit. This looks perfect. All right, so what other changes could I make? If your execution is signal generated at today's close, oh, so there might be leakage. Signal generated at today's close, buy at tomorrow's open. Original logic. Oh, so it's a data leak. In fact, understanding the specific execution timeline makes the leak even more obvious. Alright, I don't understand this. Imagine today is Tuesday. Your pipeline calculates features like RSI, MACD, Z-score using Tuesday's close. Yeah. Because you need Tuesday's close to calculate them, your model cannot generate a prediction until after the market closes on Tuesday. Since the market is closed, you will execute the buy at Wednesday's open. Calc forward sharp assigned as the target for the Tuesday row. But why would I care about the target for the Tuesday row? Because the target for the Tuesday row no. The all features are lagged by a day. This means that the OHLCV for Tuesday does not go into the metrics, the features calculated for Tuesday. Rather, they should go into the features calculated rather the features are all calculated from Monday's values. You can see by the logic in feature engine that day is not lagged by that features not lagged by at least one will be defined as targets. Therefore, there should be no data leakage. The target on Tuesday for the forward sharp should be calculated from the open Tuesday to the open on the subsequent Tuesday. I should say reassess. Stop. Reassess. Hey, Sir Night Night. Look at this. The AI is telling me there's data leakage, but I don't see how that could be happening. So it's either this is data leakage and the model is looking forward and it's not nearly as good as I think it is, but I do not believe there's data leakage. But this much of an improvement does look like there's data leakage, so or at least it seems feasible. I mean, this looks like almost perfect for me. Looks perfect to me. And look at this. I mean, so let's see what it says. Anyway, thanks. I think this is how champions are made. That's crazy. Robust annualized ICIR. I need to see if I could put this in first, though. Yes, I'm correct. I mean, that's fine. Oh, because your true execution happens at Tuesday's open, your current target is accidental, including the overnight gap. So it's slightly better. Oh my god, damn it. You're kidding me. So this isn't going to be as good, but it's not going to destroy the performance. See, it's 10:37, right? How long have I been going? Anyway, all right, so this guy's rerunning. This is so stupid. Can't I just change this guy to be open? Oh. It's fine, I'll change the function. .08. Okay, so let's see. 0.0295, 0.05. That's crazy. Standard deviation 0.1, 0.15. But it's now just 3 times. ICIR improved substantially on both. T statistic is really high now. Yeah, that was from last night. Someone posted it in the Discord. He really seems evil. I don't even know what to say about that. By explicitly setting It's hard to buy at the close. Alright, now I just need to change the registry, so feature engine, calc, forward, sharp. And then in here, forward sharp, target sharp, inputs, open. Yeah. All right, so now let's rerun this and see how it performs. But it's good for oil. That Trump tweet was good for oil. Although oil hasn't done anything, it's just been going sideways since Trump's speech last Thursday. Oh man. What would the total have been if he got Final Jeopardy? All right, so this guy's rerunning. Now I need to see, how do I incorporate momentum, calc, volatility adjusted momentum. Information coefficient, standard deviation of the information coefficient. ICIR, daily, ICIR, and annual ICIR. Okay, so let's add this to model 22. So for each window, here we'll say add volatility adjusted momentum. Okay, trial 5. Where's my charge at? Ooh, I'm down to 9%. Well, that's a problem. Task manager, what the hell is it called here? Task manager for Mac. Activity monitor. So if I don't exit out of some stuff, my computer's gonna die before this finishes. 7%. Alright, let's see if I can stay alive till this finishes. $24. %. Still at 7. Alright, so that's my next thing. Then we're gonna do walk forward analysis on model 22. So it's not improving with these trials. 7% still. Trial 28. All right, I'm gonna go get some water real quick. All right, where are we at? Trial 29, 30. Still at 7%. Okay, so these are the results with the forward target sharp. Let's just see. Come on, we got 18 trials left. I can hang out and see. Let's look more at any chats. Nope. No. What the fuck? What are the main companies working on LDV for civil infrastructure and civil infrastructure and remote industrial monitoring? What are the systems they sell? What are their capabilities? And what do they cost? Make a table for each application with results of each instrument for sale. What are the companies valued at? Trial 35. Still at 7%, good. Okay, let's add these changes. So, fixed forward sharp to use opens instead of closes. Added volatility adjusted momentum. Where did I add it in here? Good. So yeah, then I'm gonna see how that improves. If test model 1 walk forward is true, why is this glitching? What the fuck? Trial 41. Hey Derek. Well, look at these model results I got. I'm rerunning it now, but look at this. The Sharp ratio, everything's really high. Information coefficient is way better and really high. Standard deviation, so I'm only shooting for 0.01 to 0.02. I'm getting 0.05. The standard deviation of the information coefficient is only about 3 times as high as the information coefficient. About as good as it gets from this paper I found. Here's the paper. Here's the table from the paper. So the best results was standard deviation of the information coefficient is 3 times the information coefficient. And that's what this is getting. Information coefficient to information ratio, best I've ever achieved. T-statistic, best I've ever achieved. So I'm rerunning it here because I was running it on model closes, and I don't want to buy it close and sell it close of the market. I want to buy and sell at the opens. So I'm doing that now. Yeah, isn't this, I mean, this is crazy. So there's a slight chance that the new model should be a little bit worse. I don't think it's going to be much worse. It's at 46 iterations on the hyperparameter tuning, 47 now. So we got 48, 49, 50, 3 left. And then we'll see how the performance is. But my power outlet's not very good, so it's killing my power running this stuff. So I have one more improvement I'm going to try to add to the model here. And then we'll see how that does. And then I'm going to do the walk forward on the current model. So test, I'll just say model 22 walk forward. Is equal to 1. Oh, equals 0. If model 22 walk forward, so there was test 22 model 22 walk forward, oh, is equal to true. How did it do? Yeah, so it's worse, but it's still the best model I've gotten. Here it is. I mean, this is just crazy. .04 for the mean rank information coefficient is crazy. All right, so next step, try it with the momentum divided by the volatility as a feature. And then after that, run the walk forward analysis on this model. But that's it for tonight. So thanks for watching. Have a good rest of your night. Adios.